As a reminder, for more Microsoft Webcasts, you can visit microsoft.com/webcast. And again, I'd like to welcome everyone to today's Msdn Webcast, Visual C# Soup to Nuts, today's session being Part 14, Inheritance and Polymorphism. And without any further delay, I'm going to turn the floor over to today's presenter, William Steele.
Thank you, Tracy, and welcome everybody to Part 14 of my C# Soup to Nuts series. Just as we were starting this session, Tracy and I both noticed that my title is actually wrong. I'm a developer evangelist, so I'm not real sure how the community champion title got back in there, but it's not really important. I do want to point out that, as always, you can actually go out to my blog site here, blogs.msdn.com/wsteele, and go out there and bring up my latest blog entry and download the sample code for today, which we'll see that in just a second once we go into the first demo. But today we're going to cover basic object-orientedness in C#. And we're going to start off by talking about inheritance and what that actually means. We'll then move into talking about base classes and child classes, or what we call derived classes. And we'll see how those fit into the picture. And then we'll move into a little bit of polymorphism and describe what polymorphism is and how we actually implement it through virtual methods and then overriding those virtual methods, as well as just extending a class out with additional methods beyond what the base class functionality gives us. So to start off with, let's take a look at what inheritance is. Inheritance is actually pretty easy. It's a pretty easy concept, I should say. What it is it's basically the ability of one class to pass traits on to another class. You know, as we think about it from the life perspective, it's, you know, a child inheriting elements or traits from their parents. In other words, they're passed down to their the child objects, whatever they happen to be. And that's what we call inheritance. We're going to see how we can actually implement that inside of C# through our object structure. And I have a little sample here of just a really quick one that we'll take a look at sort of in our demos here. But we're going to start off with a base class of an animal. And our animal is going to be broken down into the various different types of animals. One of those types that we categorize them as mammals. Those mammals actually inherit all of the features of an animal, yet they are different from other types of mammals. Other types of animals. For example, there are reptiles, and there are amphibians, and there are, the avians, the birds, and things like that. There's various different types of animals, where mammals happens to be one type of that. So whenever you think of a object being a type of another object, a bird is a type of animal, you know, a cat is a type of feline. Those types of relationships can be expressed in a parent-child relationship where one of those objects will inherit traits from the other object. Now, in the .NET framework, every single object out there derives from one single object. And we talked about this a while ago when I did the session on classes. And that object is system.object. Now, system.object is the lowest level of object within the .NET framework. And like I said, every single thing inside the .NET framework, regardless of what it is, inherits from system.object. So let's actually go ahead and take a look at that really quick here and see what the system.object actually gives us in our applications that we can use as a basis for inheriting from and then modifying through polymorphism to suit whatever object is we need to build. So I'm going to move into a view sharing demo real quick here, and in this first view sharing demo, my screen resolution, as always, is set to 1024 by 768. So if your resolution is set to that or higher, you can press the F5 key and see my entire screen. And then once we're done with the demo, you can hit the F5 key again, and that'll restore your live meeting console back to the view with all the other content and question and answer pane and thing like that. After each demo here, you can go ahead and enter any questions that you want to into the questions and answers pane, and I will answer those as I return from each one of the demos as well. So let's move into a demo real quick here. And I do want to show my blog. First off, here's my blog. And here you can see the latest entry on it was today, a little while ago. And here is the demo code that I was talking about. You can actually download this code here and open it up and follow along with everything that I'll be doing today. Okay, so what I have here is a really simple application. It has, 4 buttons on it. And each one of those buttons, obviously, as I said before, every single object in the .NET Framework derives from system.object. Each one of these derives from system.object, as well as the form itself, which is something that we can actually take a look at. What I'm going to do is I'm just going to go into the click handler of the system.object button here, and I'm actually just going to create a new object. So we'll spin up a new object. We'll just call it O. So the object is called object. So object O equals a new object. So there I've just created some new object. It doesn't have any definition of what it is. It just is some object out there. But in the .NET Framework, every object has some base functionality that it gets included with it. One of them that I've used over and over and over in the past is the toString method. So we can actually see if we type in O period, we get 4 basic methods, and the one at the bottom here is toString. And this basically represents whatever the current object is. And there's a method on there called toString for that particular object, and we can do whatever we want to with it. In my case, I'm just going to go ahead and display this in a message box. And now if I go ahead and run this, you'll see that even though the object has not had any property set on it, has not had anything defined in it, and we don't even know what kind of an object it is, it's just a generic system.object object. When I click on the button, it tells us system.object. So the toString converts whatever, calls the method on there, and that method simply returns the value toString, which is what you're going to get if your object, whatever it happens to be, doesn't override or replace the functionality of what the toString method should be. It's just going to give you the type of object that it is. Speaking of types of objects, one of the other methods that we actually have out there in our object here, and we could just go ahead and expand this out, is the getType. This is a method that actually will give us the type of object that we're dealing with. Regardless of what it is, it will give us the name of it. So I'm just going to go ahead and run this again, and first off we'll get the system.object from the first dialog box, but the second one we're also going to see it's system.object. So we can see that the type of the object happens to be the value that's returned from the toString as well. And this can actually be used to figure out what kind of an object you're dealing with. You can look at the type and compare it with something else to see if this is the type of object that you want to deal with. For example, if somebody is passing you an object and you don't know what it is, you can simply call the getType method on it, and it will tell you what that object is. And we can use that whenever we want to. There's a couple other methods on here. One of the interesting ones that I like to show on here is the get hash value here. This get hash code value here actually gives us a unique identifier, and in fact if we hover over the methods here, we see that it gives us a description of it. This actually gives us a unique identifier, if you will, for this particular object. And it's not really unique globally, it's just unique for dealing with this particular object in this particular code. So if I go ahead and run this, you'll see what we get when we get the hash code after I dismiss the first 2 dialog boxes is a number. And this represents a hash code or a value that we can use to identify this particular object. And if it was modified or anything, that hash value is going to change. So that's basically what we get when we have an object. We're going to see how we can take this object and extend it further in the next demos coming up. But this is the basic object that we're going to be dealing with. We'll then, through inheritance and polymorphism, take this object and make it do something for us. So let me pop back over here. And hi from Peru, C# rocks again. Thanks. Post that. People from all over the world watch these webcasts. Welcome. So let's talk about base classes. We saw that object base class. That is the lowest level class in the .NET Framework. But we also have this concept of what we call a base class that we build ourselves. Now, in our examples, I'm going to build an animal-based class. And our animal-based class is going to be the root of all animals. What that means is that I am going to define a specific set of features that define what an animal is in that class. And we do that through various mechanisms. But in any event, while we're doing this, we're building a standard C# class. Now, we do have the ability to extend the class, just like we did in the class session a while ago, through constructors. We can add functionality to this that when we first build the class, we can pass in parameters to have it do some additional things. But there's a couple key points about base classes that it's pretty important to understand. We do have the ability to control who creates instances of our classes and when they create those instances. For example, if I want to prevent somebody from creating an instance of my class, maybe it's some kind of cryptography routine that I don't want anybody else to be able to implement and override, then I'm going to use the keyword sealed. That's going to lock that class down so nobody else can create an instance of that, derive from that class. They can create instances of it, but they cannot derive from it. They can't alter that class in any way. Now, the opposite of that is making a class that I can only create derived instances from. For example, if I was to go to the zoo and ask the zookeeper to show me an animal, he's going to take me to some specific example of an animal. In other words, an implementation of an animal. But he can't take me to an actual animal because there's no such thing as an animal. An animal is an abstract object. It's not something that we can go and find or create for that matter. So in that sense, we have that same logic ability in our code by using the abstract keyword on the class. Abstract allows us to say, hey, this is an object, but you can't create an instance of it. Instead, you have to derive from it. So in our case, I might have to create a tiger, which is an animal, or a hippopotamus, which is an animal. I can't create the animal itself, but I can certainly create the tiger and the hippopotamus. So in our case there, the abstract class would be animal, and the regular classes might be hippopotamuses and tigers. So let's go ahead and take a look at some of the things that we can do with these base classes and how we can actually extend those out to use them ourselves. Back over into my code here. What I'm going to do is I'm actually going to create a new animal class. I'm just going to right mouse click and choose Add Class, and we'll call our class Animal. Now our animal class is pretty much set. You notice that I haven't told it to inherit from anything. We just have this class. By default, it's going to inherit from system.object. And in fact, if I wanted to, I could even specify object, and that would look the same way. This indicates that we're going to inherit from an object, and this indicates what object we're going to inherit from. But by default, we are already doing that, so I don't really necessarily have to have that. And I can actually prove that to you by going back over to our code here and creating an instance of our animal now. Just like I created an instance of the object before, let me just go ahead and copy this code and paste it in here. We'll change the instances to A's, and we'll change this to an animal. So now I have my animal A, and then I'm calling the exact same methods on my animal A that I did on my object. Even though my animal object doesn't have any code inside it at all, it's still going to work, and all that code is going to work. All those methods are going to work the same as they would as before. You will notice that when I call in the base class here, though, when I call the toString method, we're going to get a different response than what we did before. And here we can see our toString method is giving us inheritance and polymorphism.animal. Again, same thing for the get type. And then here we have a different hash code for this particular animal. Now what that allows us to do is it allows us to actually call into an animal, and now that we have this animal that's unique from an object, we can start doing things differently to it. For example, our animal is going to start doing things for us that normally an object by itself can't do. Let's add a few things that it can do. Let's make sure that our animal can eat. So I'm adding a method here called eat. Oops, get my cursors in the right location there. And we'll just make this animal display a dialog box, system.windows.forms. So I'm adding the system.windows.forms reference here so I can get the message box. .show. We'll just say animals eating. We can do a few more methods like this. So we have eat, we have walk, and we'll do one other, talk. So our animal can eat, walk, and talk. Now these are things that an animal can normally do. However, the object doesn't do them themselves. So when we go back and we look at our code, these are things that the object does, but we also have added functionality that the animal can do itself. And here we can see we can have the animal eat, we can have the animal talk, and we can have the animal walk. Yet all of the other functionality from the base class object is still there. So if I go ahead and run this, click on my base class, here we get the first 3 dialog boxes, and then we're going to get the eat, we're going to get the talk, and we're going to get the walk dialog boxes. So there we've added functionality, we've extended the base class object with new functionality particular to the animal. And that's actually pretty important. Some other things that you can do with the animals, when I create an instance of an animal, I can actually have it do some additional work. So we'll just create a constructor here called animal. And our animal will simply say it's an animal. I'm an animal. So when we run it this time, I'm going to get the constructor firing once this object is created, which is going to happen actually up here. So I'm going to go ahead and put that breakpoint on there. We'll go ahead and click that button. And there we can see I have my breakpoint hit. If I step through this code, you'll notice that the first thing that fires is the constructor, which is the I'm an animal dialog box. And then it's actually going to drop back out and continue to run the following code, or the rest of the code. So the standard object stuff applies, and then the animal specific stuff applies. So there I have a basic animal that can do a few basic things. It can walk, it can talk, and it can eat. And it lets us know that it's an animal when we're creating it. Now you remember a little bit ago I was talking about that abstract and that field class. Now we can't actually create an instance of an abstract class. So in reality, I can't create an animal. I can only create something that derives from an animal. So we're going to tell the system that, hey, this is actually an abstract class. It's not something that we should be able to create an instance of. So when I type in the word abstract and I try to run this again, we're going to get a compiler error that says, hey, you can't actually create this because this is an animal. You need to create derived instances of this. So we're going to see in the next section how we're going to handle this. But for now, I'm just going to go ahead and comment that code out so that it doesn't continue to cause us problems. And we'll go ahead and pop back over to our code here. And Tom is asking, what is void? Actually, that's a great question. When I type in the word void there, what it's doing is it's saying that I do not want to return anything from these functions. These are functions that do not return a value. If I was to return a value, I would, instead of using the word void, I would use the word whatever the type is. So it might be a string or an integer or something like that. In our case, I'm not actually returning anything, so I simply use the word void, which says, hey, I'm not returning anything. That's all that does. Okay, so we saw our animal there, and we saw that when I created the animal class, I was able to use it. But then when I change it to an abstract class, the Visual Studio gave me an error saying, hey, I can't create an instance of that abstract class. And what it would like me to do instead is to create a class that derives from that animal. In other words, an instance of a class that I can actually create, yet inherits all the features of the animal. In our case, what we're looking for in that case is, maybe a cat or a dog or something like that. So to create an instance of a class that derives from another class, we simply, in the class description here, We have our class keyword, then we have the name of the class, then we use the colon, and the colon lets us know that we're going to be inheriting from something. And then the following parameter is the actual name of the class that we're going to be inheriting from. Now, as we do that, we automatically gain all of the features of the actual base class without having to write any of that additional code. So when I create an instance of a cat that inherits from animal and an instance of a dog that inherits from animal, they both get the eat, the walk, and the talk methods, as well as the base class constructor method that says I'm an animal, for free. They don't have to re-implement any of that code. Now that is where our code reuse in the .NET framework really shines. Anytime you're doing something like that, you're only writing a little bit of code, but it extends to every child object that inherits from that. So they can all use that code over and over and over, which is actually pretty nice. It allows us to reduce the amount of code pretty vastly. Now we do have the ability to override that, which we'll see in the next section. But for now, I also want to point out that we have the ability to actually call into the parent class's constructors as well. So just like I was able to call the methods in the animal class, as well as call methods on the object class from the animal, I can also call the constructors and even forward one constructor call to another constructor call through various different mechanisms. So here's an example here where I have a public constructor, and I use the same colon that I do on the class, but in this case I'm using the constructor and I'm just telling it to call the base class constructor. This example down here, I'm actually having it call a constructor on the same class, but I'm adding an additional parameter to it. So in this case, it allows me to specify some more details about what's going on inside there. So let's go ahead and build a couple derived classes. Oops, I just clicked on the wrong link there. Let me get to the right one. Build a couple of the derived classes here based off of our animal there. Okay, so first off, to build a derived class, what I'm going to do is I'm actually going to go ahead and add another new class. Add a class. And we're going to call this class our dog. Now our dog is just like our animal was before. It doesn't do anything extra, you know. It's basically a simple dog. However, what we'd like to do is to tell the system that what I'd like this dog to be is an animal. So simply by specifying that this dog is an animal, I now gain in my dog class all the functionality that an animal has. And we can see that by going down and, again, creating an instance of our dog. Just like we created an instance of our animal before, we're just going to spin up a new dog. So dog D is equal to new dog. And we can then call in, just like we did before, the same method that we have here, the eat, the talk, and the walk. So our D eat, D walk, and D talk. These allow us to have an animal now. Remember before we weren't able to create the animal because the compiler gave us an error saying we couldn't create an instance of the abstract class, but because the dog is actually a derived class from animal, I'm going to see that those are going to allow me to work. So here's my dog class. It says I'm an animal, animal eating, animal walking, and animal talking. So those are instances of that is an instance of an animal, but it's particular to a dog. Now, dogs are a little different than base class animals. In fact, in this case, we have an animal that says messagebox.show I'm an animal, but it doesn't say what kind of an animal. But our dog, we might want to have it actually specify what kind of an animal it is. Or maybe even not. Maybe we just want to make sure that it lets everybody know that it's an animal. Because remember when I created that constructor there, when I created my dog, it didn't actually pop up and say, hey, I'm an animal. It simply said, it just simply did whatever it was supposed to do, right? Just called those three methods. But it didn't actually call the base class animals. So what I'm going to do is I'm going to have the class in here automatically do that for me. But I'm actually going to take it a step further. I'm going to add another animal method here, another animal constructor, that allows us to specify a parameter. We'll just call it the dog's name. Now in here, in my code, I'm just going to add a little bit of my name is, and we'll pass in the name. So now I have an animal that takes an additional parameter to it that allows me to specify what the name of this animal is. And that's going to display that in a dialog box. If I go back to my dog now, I can actually specify that my dog has a public constructor as well, just like we did before. And I could do anything that I wanted to inside here, but I'm going to do something entirely different. Instead of specifying that I'm a dog inside here, I'm actually going to call the base class, and I'm going to pass in a parameter. You'll notice that the base class, when I type in the word base and open parentheses, it gives me animal.animal, which is the class and the constructor. But we have two constructors here. So if I move down, you'll see that I have one that can take an optional string name. So I'm just going to go ahead and pass in Fido here. And this is going to allow me to have a dog that actually passes in a parameter to the base class called animal, and then the animal class can go ahead and execute whatever code it needs to based on that name coming in. So in this case, it's going to display a dialog box that says that my name is, and this, in our case, Fido. In addition to it, dogs do a lot more things than normally what an animal does. One of the things that a typical dog would do is play fetch with you. So we can actually specify, we have a fetch method. So play fetch. So now I have a dog that not only can eat, walk, and talk, it also has a name, and it can play fetch, which is different than what a base class animal can do, because a base class animal can only eat, walk, and talk. And if I wanted to create an animal, I could, but because this is abstract, I can't create an instance of the animal class directly. So let's go ahead and add one more item here. We'll call this our fetch. So we can see that our dog is now able to fetch in addition to everything else that an animal can do. And I made a mistake somewhere along the line. Oh, I forgot the using system.windows.forms in my dog class. So now my derived class called dog is an animal, and his name is Fido. So there we see that. We can also see that the animal is eating, walking, and talking, and it's also playing fetch. Now, this brings us to a point that we're going to start getting a little bit more advanced here. And that point is that when we're looking at our dog right here, our dog can do everything that an animal can do and more. However, there are things that a dog can do that animals can't do, or that dogs do differently than the typical animal. For example, when we say talk, a dog talks in an entirely different way than other animals. It doesn't use a generic talking mechanism. So we're going to see in this next section how we can use polymorphism to change how the dog actually talks or walks or whatever it is that's different from any other type of animal that's out there. So I got a couple questions in the queue here, and let me bring those up real quick. So Carl's asking a great question. If I inherit from a class that inherits from a class, do you inherit from both? As a matter of fact, you do. If you saw my dog there, I could just as easily go and in my dog class bring up the toString method, the dog.toString or the dog.getHashCode. Those are inherited from the base class object. So we can go all the way up the tree. And at any point, we can actually override those, which is what I'm going to show in just a second there. Dan's asking, do extra unneeded using statements incur any overhead, or are they only used to aid the compiler and IntelliSense? Actually, Dan, that's exactly right. They don't do anything. They don't add any additional code. They simply allow us to reference the code. So it basically allows us to get access to the namespaces and classes. I could have, if I wanted to, simply typed in all out, system.windows.forms.messagebox.show, and that would have been the same thing, and I wouldn't have needed the using statement. So basically all it does is it shortcuts the IDE. And in fact, when you go out to your code and you actually compile it using command line tools and things like that, you don't need the using statements. You actually add a reference to the compiler itself. Okay. So Let's talk about polymorphism. Polymorphism is where we can take our classes and change them, changing over time, kind of like evolution. Evolution of our classes is actually pretty significant. It allows us to change the functionality based on whatever reasoning we have. So an animal might perform a different type of function, like walking and talking, entirely differently from other animals. A kangaroo walks in an entirely different way than a dog does, which walks in an entirely different way than a human does. So those are different instances of walking, yet they are implemented entirely differently. So we use polymorphism to allow us to change that. We also have another form of polymorphism where we can actually change the methods themselves. So a lot of people will call this overloading. It's still a form of polymorphism where a single class can actually override or add new functionality to older classes. Think of versioning code. The first version of code might, have a single parameter on a method. The second version of code will implement or inherit from the first version, yet add a new method that also takes an additional method, for example. So we have the ability to add additional functionality to our base classes at any time we want to. Now we do this through a couple different ways. First off, our base class has to allow it. Allow a method to be overridden. And in order to allow a method to be overridden in the C# class, it must be marked virtual. So basically what we do is in our base class, we simply add the word virtual to any method that we would like to be allowable to be overridden. So in the walking and the talking and the eating methods of my animal base class, they are not marked virtual. So that means I cannot change their functionality. They're locked in the way they are. As soon as I add the word virtual, I'm going to be able to go ahead and change that functionality. Now to change that functionality, I'm going to use a method, or I'm going to use a keyword called override. Override allows me to change any method that is marked with the keyword virtual. And basically, I'm going to do it this way. In here, I'm simply going to, in my child class, I'm going to use the override keyword on the method, which is going to allow me to replace the functionality that existed in the base class. And if I wanted to, I could even call into the base class's functionality afterwards by using the base dot and then whatever that method happens to be. The base object is still available to me and still allows me to do anything I want to with it. So let me go ahead and pop into the override and the virtual methods here. And we'll take a look at how that works. So here I have my animal class. Now I talked about the eating, the walking, and the talking, that I'd like to be able to change those for my dog class, or even another class that I'll be coming up with in a second. To do that, I need to mark these as virtual. So I'm just going to add the word virtual to them. I'll copy that, paste that there, and that there. And that allows my methods now to be overridden. Now in my dog class, I'm simply going to override those. In fact, let me just go ahead and create a new class altogether here. We'll call it a cat. Now our cat class is actually going to override all of the functionality that was in the dog or in the animal class. So to do that, first off, I need to inherit from the animal class. And now I need to go ahead and type in some new methods here. Public. Remember, we have void eat from the base class, but I'm actually going to change this, and I'm actually going to use the word override. So public override void eat. And again, I'm going to need my, let's see, using message box, show cats lap when they eat. Notice how when I use the override keyword, it gives me a list of all the functionality that can be overridden in the base class. And when I type in the word void and I hit the space bar, it narrows that down to just the methods that actually return something, which is interesting. These return just the same type, but you notice that eat isn't in that list because it recognizes that I've already overridden eat, so I don't need to do that anymore. So I can do that. Here you can see me calling the base class functionality base.talk. This is an example of it's what would normally happen when I create an instance of a cat. This is just going to call the base class version of it. I'm just going to go ahead and replace that with this, and the cat's going to do a meow, and then public override, spelled correctly, and we'll do the walk. And then in this case, a cat's going to strut. One other thing that a cat would do over any other animal, public void purr. So this is something that's unique to cats. So I've added some new functionality to the cat. I've also overridden all of the previous functionality that was exposed through the animal class. And I've decided not to implement the constructor there. So let's go ahead and create an instance of this guy inside our actual application here. So cat c equals new cat. And then we get the c.talk, c.walk, c.eat, and obviously c.purr, kind of just like what we did up here in the dog. So here we can see eat, walk, and talk are available to both animals. The unique portion of a dog is fetching. The unique portion of a cat is purring. Those are differences between those objects, yet they all derive from animal. By the way, somebody was asking about multiple inheritance, or inheriting through, I shouldn't say multiple inheritance, but inheriting through the chain. So we can see that we have the get hash code, we have the get type, and we have the toString methods that are also available from the base class object. So those are all there as well. And now when we go ahead and run this, though, our virtually overridden methods inside of our animal class allow us to say, well, here's the constructor for the cat. Now we have the meow, the strut, and the lap, which are unique to the cat, as well as the purr, which is actually new functionality. So we've basically overridden the methods that were available in the animal class, replaced them with our own implementation. And I didn't have to do all of them. I could have just done, a couple of them if I wanted to, or the ones that I really needed to. I don't have to do every one of the classes. And I can mix and match these. As a matter of fact, if I wanted to, I could go even farther and actually create a new instance of a cat that overrides even more functionality. So for example, I might have another class here called tiger. And tiger is going to inherit from cat. And now my tiger gets all that functionality. I could mark this guy virtual. So I have a purring that's virtually, the lap, the meow, and the struts are pretty much going to be available. However, the tiger is actually going to have a loud purr, for example. So a public override void purr, and I might make this maybe two of them instead of one, or a loud one, whatever it happens to be. So I've changed the way this works, and now if I create an instance of the tiger, the purring would be doubled for the tiger as opposed to the standard cat. So that's just an instance of some of the things that we can do there. Now, one of the items I do want to show you here is I'm actually going to go ahead and add one more item to this. In this case, this is a cat. And it's meow. It's pretty specific to an animal. I'm actually going to mark this as sealed. I talked about abstract earlier. Sealed allows me to say, hey, I cannot create an instance of this. Now I have this tiger out here that's already spun up as an instance. When I try to build this, you'll see I'm going to get an error. I cannot derive from a sealed type. It's locked. It does not allow me to do that. Just like before, when I marked the abstract, when I marked it as abstract, I had to create an instance of, derived from that instance of the animal. In a sealed, I cannot derive an instance from it. I'm not allowed to do this exact code here. So this is the opposite of what the abstract is. So remember, abstract means I can't create an instance of this one, where sealed means I can no longer create instances of it. In an animal class, though, I have to create a derived instance if I want another one. A cat, I can simply cannot create another one. So in our case, a tiger might have to inherit from animal instead. and then that would be fine. However, this functionality right here would have to be duplicated because the purring doesn't exist in the animal. So we have some interesting things to deal with when we're doing that. By the way, you'll notice that once it's marked sealed, it doesn't even show up as an optional class that I can actually derive from in IntelliSense. So that should give you a good indicator that a class is sealed if it doesn't show up when you try to create instances of it. So those are some examples of how deriving works, how creating base classes, and how you can create functionality in a base class and override it in the child classes, how you can add new functionality to the child classes, how you can lock people out from adding new functionality, or how you can force people to add new functionality. Based on what it is that you're trying to do, you can see in this scenario we've pretty much covered every type of scenario there is when we have multiple objects. For example, we have multiple types of objects that derive from a single object. Here we have the cat and the dog that derive from animal. The ability to have the animal base class react differently based on whether it was created by itself or created with a name, an additional parameter, like we did in the dog class here. Here we have the dog base class actually passing in a parameter into it. We could do that with all the others. And then we also saw how we can add some new functionality that's unique to each one of the different types of animals that's available there. So I've got some questions in the queue here. I do want to go ahead and pop out to the summary real quick here. And we talked about inheritance. We talked about the base classes and child classes and how we can create an instance from one to the other simply by using the colon identifier. We then moved into polymorphism where we learned how to change a base class to make it perform some new function that's specific to the new type of child class that we're building. And we did that through virtual methods and then overriding those virtual methods. And we also learned about the abstract and the sealed keyword, where abstract forces us to create a different type of object based on this class, and a sealed object forces us to not to be able to do anything beyond what that class already does. So it kind of locks that in, and showed some examples of each one of those. I do want to thank everybody for stopping out today. I want to remind you that next week we do have a new we're moving into a new area of the C# Soup to Nuts series where we're actually going to be talking about implementation details. So next week we're going to be looking at how C# fits into the web, and specifically ASP.NET, and how we can use C# to actually build web pages and reusable components within our websites. So thank you for watching today's webcast. Don't forget we have all kinds of other webcasts here. Go out to Microsoft.com/webcast. As well as my blog, you can keep up to date on what's going on in my blog. Feel free to send me emails anytime, blogs.msdn.com/wsteele. I do have a backlog of those. I'm getting to those this week. I had a really, really busy week last week, even though I wasn't working, believe it or not. My manager would love to hear your feedback. Her email is mbrune@microsoft.com. Love to hear your feedback on this webcast or any other webcast or any of the live events that I do from msdnevents.com. So at this point, I'm going to go ahead and turn it back over to Tracy, where she'll get you into the survey. And while you guys are in the survey, I will be answering all of the questions that are in the queue. Tracy?
Excellent. Thanks, Bill. And remember, for more information, you can print a PDF of today's session. And in order to do that, just go to the File menu in your upper navigation bar. We will be getting to the questions and answers here shortly, so go ahead and feel free to submit your questions to us now. Also, I'm going to be posting a survey here in just a minute. If everybody would please take a moment to fill it out before you log off. We do appreciate your feedback. For upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can go here to access this webcast and the first 13 webcasts in this series. If you have any webcast content ideas, if there's something out there you'd like to see and haven't yet, we would love to hear from you. Just take note of this link here. And if anybody's interested in receiving a free 14-day trial of Microsoft Office Live Meeting, you want to visit Microsoft.com/presentlive. Now for filling out that survey today, you're going to be automatically entered in to win this 30 gigabyte Microsoft Zune digital media player. Gives you a little incentive to fill that out for us today. And here's the survey. Please follow the links provided to complete today's webcast evaluation. And Bill, looks like you do have some questions waiting for you.
I've got quite a few of them in there. So MGM is asking, can I please address the issue of multiple inheritance? Well, actually, I'm not real sure what kind of an issue you're talking about. There is no issue of multiple inheritance in C# because multiple inheritance doesn't exist in C#. I'm not real sure what you're looking for. Multiple inheritance, I don't want to confuse everybody, so it's not something that we have to deal with in C#, so I would prefer to avoid that. If you go into C++ or other languages, there is this concept of being able to inherit from multiple objects simultaneously. We do not have that in C# or in any other .NET-based language, so we don't have to worry about that. Tom's asking, I don't understand what the difference between virtual and overrides is. Well, actually, virtual just lets us tell the so if I have a method that's marked as virtual, that means anybody is allowed to override me. A method that's marked as override is overriding or replacing the functionality of a method that was previously marked as virtual. So virtual is the keyword that says I'm allowed to be overridden. Override is the keyword that says I am being overridden. So hope that makes sense there. Let's see here. Now we have. Let's see where I just lost my point. Is there a tool that will read the project and produce a graphical representation of classes and their relationships? Actually, Bill, that's actually a good question. There is plenty of tools that actually do that. As a matter of fact, the one that comes right off the top of my head is Visual Studio Team System. Visual Studio Team System does that out of the box. You can open that up and actually view a class diagram that we call that of that right away. Simply by opening it up and opening it up in a class diagram. Okay, Lou's asking, is the dog class now broken since the methods in animal are all virtuals? Actually, no, the dog class is not broken. It's just that the dog class has not changed the functionality by overriding the function of the animal class. So just because those methods are marked as virtual doesn't mean I cannot call them or cannot use them as they are. So that would be that would cause all kinds of problems if we weren't able to call those. Wells asking, can I use base class reference to point to child class and call virtual methods as in C++? Can I use a base class reference to point to it? Okay, I'm going to have to need a little bit more information on that question, Will, before you can see what you're looking for right there. Dan's asking, when the constructor for a derived class runs, does it also perform its parent's constructor? Actually, that's a good question, and the answer to that is yes. When the constructor for a derived class runs, it will call the parent class's constructor if you haven't specified that you don't want it to. So using the base method, you can actually call it. You can do it from within the base class or within the constructor, or on the actual line where you're actually creating the instance of the constructor using the colon keyword. Dale's asking, using this example, can you show an example of using a sealed class? How do you instantiate it? Actually, the cat class is a sealed class. You would create an instance of that class just the same. So, cat C equals new cat. However, you cannot create a derived instance from it. So, for example, the tiger, which was derived from the cat, I'm not allowed to create because it is marked as sealed now. Wow, my questions just got all out of order. Steve's asking, if walk isn't virtual on cat, can tiger override it? Let's see here. If the override talk. So in our case there, I'm looking at the code here. I've got it marked as override, and the cat is actually overriding it. However, tiger is actually going to be overriding. A tiger can also override it because the base class that it's implemented from is marked as virtual. So the answer to that question is yes, tiger can still override the walk method, even though the cat has already overridden it. Because remember, tiger, the base class, the base method is actually marked as virtual. So as long as it is marked as virtual, then we can do that. In C++, can there be a friend? I guess what you're asking, is there they're the equivalent of the friend in C# that you have in like C# and C++. And actually, yes, it's called internal. You can actually mark it as internal, and that would do that. Can I require a methods implementation in a derived class? Can I require a methods implementation in the derived class? Yes, you can require that. You would do that through the interface. So instead of inheriting from a class, you would inherit from an interface, which would force the method implementation there. Can you have a virtual override method? You do not need a virtual override method. As long as the base class is marked virtual, any of the childs can actually override it until you actually lock it out. Since base class constructors are run, do they run for every child, and is this performance heard if that base class is run many times? Well, it depends on what you're doing inside the base class constructors. You have to be very careful there what you're doing. You can, by simply not specifying that you have a constructor, it will run. But if you specify you have a constructor but don't put any code in it, then nothing is going to run in the parent class. So basically, you've overridden it and you've told it not to replace that functionality. So that's completely up to you, however many times you want it to run. It depends on what your architecture of your class structure is. And actually, I don't see any other questions in here.
All right, Bill, what we can go ahead and do then is just take any more questions then through the text manager if you want to.
Yep, that'll work.
All right. Well, with that, I do want to extend a very special thank you to Bill for your presentation today. I'd also like to thank the audience for attending today's Msdn webcast. Ladies and gentlemen, this does conclude today's session. The audience may now disconnect from the audio portion of today's presentation.